You're listening to the Bare Metal Cyber Prepcast, created to help you succeed in your Server Plus certification journey. Learn more at baremetalcyber.com, where additional prepcasts, books, and training materials await. Let's get started. High-speed network interfaces form the data arteries of the server environment. As application demands grow and data centers evolve, systems require faster connections to move larger volumes of traffic. From basic file sharing to virtualized workloads and data replication, network interfaces must scale accordingly. Technologies like Gigabit Ethernet, 10 Gigabit Ethernet, and modular optics provide the performance foundation for modern infrastructure. Server Plus includes high-speed interface awareness because every deployment hinges on understanding speed, compatibility, and media alignment. Choosing the right interface is not only a technical decision, it's a strategic one. Interfaces must be matched to physical cabling, available switch ports, and server capabilities. When mismatched, links may underperform, fail to negotiate correctly, or simply not operate. Choosing the wrong transceiver or incompatible port module can slow down a critical server, restrict bandwidth for a backup job, or degrade video and VoIP performance. Server Plus emphasizes correct selection because high-speed interfaces must align with cost, deployment scale, and service continuity goals. Gigabit Ethernet, often labeled as 1000 base T, remains the baseline for many server connections. It delivers 1 gigabit per second over standard twisted pair cables, typically category 5E or higher. It uses RJ45 connectors and supports distances up to 100 meters. This makes it ideal for connections between servers and access layer switches in the same room. Because of its compatibility and affordability, it continues to be deployed in small and mid-sized environments, even as faster standards grow more common. 10 Gigabit Ethernet, or 10GBASET, is the next evolution of twisted pair connectivity. It delivers 10 times the speed of Gigabit Ethernet, while still using copper cables. However, it requires Category 6A or better cabling to minimize signal degradation and crosstalk. Like its predecessor, it also uses RJ45 connectors and is backward compatible with 1 gigabit interfaces, allowing flexible integration during upgrades. Server Plus includes 10GBASET as an important interface for high-throughput applications like virtualization hosts or clustered databases. In addition to twisted pair, optical standards provide high-speed connections over fiber. 10GBASESR is designed for short-range multimode fiber runs and supports distances up to 300 meters, depending on the fiber grade. 10GBASELR supports long-range single-mode fiber and can reach up to 10 kilometers, making it suitable for inter-building links or campus-wide deployments. These optical standards allow administrators to match performance goals with existing cabling infrastructure and distance requirements. Small form-factor pluggable modules, or SFP modules, are compact transceivers that plug into compatible switch or network interface card ports. Standard SFP supports up to 1 gigabit per second, while SFP Plus modules support 10 gigabit speeds. These modules make it possible to use copper or fiber as needed, based on the insert. Administrators can change media types without replacing the entire switch, which improves flexibility and supports hybrid rack layouts. Server Plus includes SFP knowledge as part of modular interface deployment. Quad Small Form Factor Pluggable Modules, or QSFP, take this concept further. QSFP modules contain 4 channels that can support up to 10 gigabits each for an aggregate total of 40 gigabits. QSFP Plus and newer generations extend this to even higher speeds. These interfaces are essential in spine leaf architectures and core switching layers, where aggregation and inter-switch links must carry high volumes of data. Server Plus includes these modules because they support scalable, high-performance network design. For short distance, high-speed connections like between 2 switches in the same rack direct attach copper cables, or DAC, are a cost-effective option. These are passive copper cables with fixed transceivers on each end. They eliminate the need for separate modules and are designed for distances under 10 meters. While limited in range, they are fast, low latency, and energy efficient. Server Plus includes DAC as part of high-speed rack cabling knowledge. Active optical cables, or AOC, are similar to DAC but use optical fiber instead of copper. These cables have integrated transceivers at each end and support longer distances with better immunity to interference. AOC is ideal when modular optics are not needed, but the performance benefits of fiber are required. These cables are plug-and-play and simplify deployment when pre-calibrated runs are acceptable. Auto-negotiation is a valuable feature in many high-speed interfaces. It allows devices to determine the best shared speed and duplex settings during link setup. However, not all devices or transceivers support fallback properly. A mismatch between an SFP Plus port and a 1 Gigabit SFP module, for example, may prevent the link from establishing. Server Plus includes compatibility awareness so candidates can identify misconfigured or unsupported combinations in modular environments. Transceiver labeling is critical for inventory management and troubleshooting. Each module should display its supported speed, wavelength, connector type, and maximum transmission distance. These labels help prevent accidental mismatches and reduce the time needed to identify why a link is failing. Technicians should document each transceiver as part of the rack elevation diagram or switch port mapping process. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Welcome to the Bare Metal Cyber Server Plus Prepcast. This series helps you prepare for the exam with focused explanations and practical context. As data speeds increase, so does the demand placed on power and cooling infrastructure. High-speed interfaces such as SFP Plus and QSFP modules generate heat during operation. Each transceiver contributes to the thermal load inside a switcher server. If too many high-speed ports are grouped closely without sufficient airflow, localized hotspots can form. These can cause transceivers to throttle performance, produce errors, or fail prematurely. Technicians must plan port spacing carefully and use blanking panels or fan trays to maintain airflow. Server Plus includes port thermal awareness as part of physical design best practices. Port density and chassis slot limitations also play a role in interface selection. Some switches and modular chassis allow only a specific number of high-speed ports to be active at once, either due to electrical limits or licensing restrictions. High-density configurations must balance performance needs against physical and electrical constraints. Not every module type fits in every slot, and some uplinks may require shared or composite slots that affect total port count. Server Plus includes understanding slot limitations when designing scalable uplink strategies. Vendor compatibility is another important consideration. Many networking vendors lock their equipment to only accept transceivers that are vendor certified. Using third-party optics may work physically but result in warning messages, reduced support, or even port shutdown. While third-party modules can save money, administrators must understand the trade-offs. Server Plus emphasizes this awareness because incompatible optics can delay deployments or complicate troubleshooting, especially during audits or service contracts. Modern SFP and QSFP modules often support diagnostic and monitoring features. Digital Optical Monitoring, or DOM, allows administrators to read real-time data from each transceiver. This includes signal strength, transmit and receive power levels, temperature, and voltage. These metrics can be accessed through the switch's management interface and used to detect cable issues, degrading modules, or environment-related failures. Server Plus includes optical diagnostics as part of ongoing infrastructure monitoring. High-speed interfaces often serve as uplinks between access layer switches and the core or aggregation layer. These uplinks carry multiple lanes of traffic from many downstream devices, making performance and resilience critical. Aggregation strategies include link aggregation using LACP, or channeling multiple uplinks into a port group to increase bandwidth and support redundancy. Spine-leaf network topologies also rely heavily on high-speed interfaces, with spine switches connecting to leaf switches at 40 gigabits or higher. Server Plus includes uplink planning concepts as part of scalable network design. Servicing high-speed transceivers requires attention to both physical care and operational matching. Most modules are hot swappable, meaning they can be inserted or removed while the system is running. However, they must be matched to the exact speed, fiber type, and connector standard. A mismatch may prevent the link from coming up or create intermittent errors. Technicians must also handle transceivers carefully, using ESD protection and keeping dust caps in place until installation. Server Plus emphasizes hot swap safety and handling as part of rack-level maintenance. Every interface must be documented. Diagrams should include which transceiver is installed in each port, what speed it supports, and where it connects. Documentation should also track which ports are active, which cables are used, and which interfaces are configured for uplinks, backups, or aggregation. This level of detail supports rapid troubleshooting, simplifies audits, and helps plan for upgrades. Server Plus includes documentation discipline as part of full-cycle infrastructure management. High-speed interfaces allow server networks to scale. From gigabit to 10 gigabit Ethernet, and from direct attach copper to modular QSFP optics, each link must be designed, labeled, monitored, and maintained with precision. Speed alone is not enough. Compatibility, airflow, and long-term reliability all play a role. By mastering interface technologies and transceiver planning, Server Plus candidates can design environments that are fast, efficient, and resilient. In the next episode, we move from interfaces back to the cables themselves, focusing on best practices for high-speed cable labeling, signal integrity, and layout consistency across racks and floors. Thanks for tuning in to the Bare Metal Cyber Prepcast, your trusted source for cybersecurity news and insights. Remember to subscribe at baremetalcyber.com so you never miss an update. And visit cyberauthor.me for best-selling cybersecurity books that equip you with expert knowledge. Until next time, stay secure and stay vigilant.